Okay. Good evening, everyone. So, I am SHAKSHI Bhardwaj. I am a TA of Professor Shishir Sinha in Chemical Engineering Department of the course Polymer and Process Engineering. And this is the assignment 11 related questions. We are taking a problem solving session 11th, which is second last now. And I am a PhD scholar in Professor Pradeep Kumar Maji's supervision in Department of Polymer and Process Engineering, IIT Roorkee. So let's start today's session, starting with the brief introduction of mine. So yeah, as I told you, I'm in Department of Polymer and Process Engineering, Indian Institute of Technology, Roorkee. I'm a PhD scholar under the supervision of Professor Pradeep Kumar Maji, and the topic of my thesis is fabrication of cellulose-based aerogels for thermal management applications. Apart from this, I have completed my master's from Maharishi Dayanand University, my bachelor's from Kirodimal College, and apart from this, I've already conducted two projects, one in Institute of Technology Roorkee over the lightweight thermal super insulating aerogels, and another one in University of Delhi over the repurposing of drugs for SARS-CoV-2. So let's start today's session. So in the previous two sessions, we have done the polymers like polymers applications and testing, but and now this is the extended session of the last one in which we have done the electronics and the polymers which we can use in electronics. This is also similar like this for applications of this. And in the other session also we will going to take applications. Now these three sessions are totally applications based where we just need to understand like what kind of polymers used in different what kind of areas. So starting with like coatings. So in this session, we are generally taking the coatings. Yeah. So starting with like what are coatings? And we everyone and we generally knows like coatings are thin layer of material applied to surface of object to protect them or to enhance their appearance or provide specific functional properties. They can be made from a variety of substances including paints, varnishes, polymers, metals, or ceramics. And the general example is like we paint our homes. So this is also a kind of coating. And we protect our home like from the moisture, and there's several type of coatings can be performed. And the jewelry we wear, there's also coat. So many of the things like we use in general life, they are coated. And the purpose of coating is many, like to brighten their appearance, to protect them from the environment, and to bring the shine in that. And that's the certain kind of coatings can be done. So there's like for purpose of coatings. So first, it's the protections. The coatings protect surface from corrosion, wear, weathering, UV radiation, chemicals, and moisture. For example, metal parts are coated to prevent rust. So generally, like iron, we use, and iron is susceptible to rusting very much in the presence of moisture. So that's how we can coat iron, and we have read the process of galvanization and like the coating of zinc over iron to protect it from the rust. And this is why we used alloys most of them, like the steel, because it cannot corrode very much. And other purpose of the coating is aesthetics, like the appearance by providing color, gloss, or texture, that it will look good when we use that. The other purpose is the functional properties, like some objects or coatings add special properties like electrical insulation, water repellency, anti-fouling, or antibacterial effects. Like in the previous sections, we have read the polyurethanes and different epoxies and silicones. We can use coatings for the electric insulation because they are the polymers which provide electric insulation as well as the protection from moisture, dust, and everything. And that's how the properties can be increased. And similarly, anti-fouling and antibacterial effects can also be imparted after these type of coatings. So this is the purpose of coatings. Now come to the type of coating. So there are several type of coatings. The first one is the protective coating, such as anti-corrosion paint or steel structures. So they can protect. Other one is decorative. So they can decorate, like the automotive paint or the wood varnish. The functional, which anti-reflective coating on lenses, thermal barrier coatings on turbine blade threads. And these kind of coatings can be used in construction, automotive, aerospace, electronics, packaging. And that's how the durability, safety, performance of any kind of product can be increased. So this is the basic overview of why coatings performs, how different type of coatings can be done, and this and that. So let us take some questions over these kind of coatings. So first is like, which property is most critical for coating used to protect electronic component in harsh chemical environments? So what kind of coating can be used to protect electronic component in harsh chemical environments? And the options are the high thermal conductivity, which have, or the resistance to chemical solvents, which can give the electrical conductivity or the optical transparency. So which kind of coating can be used to protect electronic components? Okay, so I guess this is not that typical question because it's very if you look at the options, we can easily resist or we can eliminate the options and just keep the option which is most relevant. And I got two answers, which says it's P, resistant to chemical solvents. And yes, it's true, it's P, resistance to chemical solvent. And we look at the other options like a high thermal conductivity, the electrical conductivity, or the optical transparency. These type of coatings can be done for the special purpose, but they cannot protect the electronic component in harsh chemical. Only the resistance to chemical solvents, which can protect in the harsh chemical environments. That's why these type of coatings can be performed. So the reason is the harsh chemical environment in electrical component are exposed to various solvents and corrosive that it can damage or degrade their performance. Therefore, the most critical property for protective coatings in such conditions is resistance to chemical solvent. This ensures that the coating acts as a strong barrier preventing chemicals from reaching and harming the sensitive electronic part. Other properties like thermal conductivity, electrical conductivity may be important for other functions, but when it comes to chemical protection, chemical resistance is essential to maintain the longevity and reliability of electronic devices. And that's why I'm saying that chemical resistance is the basic minimum key requirement to protect the electronic component in harsh chemical requirements. Other type of coatings can also be performed depending on the requirement one have in that case. I hope this is a very simple question, and as everyone get through it, and this type of questions we have taken in the last session also, like most of the polymers we have read in which these type of coatings can be done to protect them, to protect electronic items from these the environments and other things. So let's move forward to the next. So yeah, acrylic. So this is the acrylic coatings, and it is very important. If you look at the structure of acrylic, this is kind generally the acrylics, and that can be made from acrylic acids or methacrylic acid, methyl methacrylic. You already have heard this MMA, which can be used to form PMMA. PMMA is a very common and very known polymer generally used and because of its shiny appeal or the transparency it has. So acrylic refer to a family of synthetic polymers derived from acrylic acids, generally this kind of acid in which this has a double bond and the acidic group. And this double bond can help for the reaction medium. This we have read about the polymeric reactions in which we read about the free radical reactions. So these kind of polymers generally show the radical reactions, free radical reactions. And the most common form is polymethyl methacrylate, often referred to simply acrylics or by trade name like plexiglass, lucid, and perspex, etc. It is a transparent thermoplastic known for its glassy like clarity but with better durability and flexibility. And acrylics are generally lightweight. They are transparent plastics with excellent clarity and high impact resistance. And that's why, because they have the transparent plastic which has transparency, so these type of polymers can replace glass. Because glass, this is not lightweight and can be not that flexible, so it can be breakable easily. So these kind of polymers can replace glass easily. And if we look at the other properties, like they are weather resistant, do not yellow under sunlight, and are easier to shape than glass. And acrylics are also good electrical insulators. So this is an important property also, and available in many colors. So however, they can scratch easily and less impact resistance. If you look at the glass cannot be scratched. It can be shattered. But if you look at the polymeric or the transparent polymers, it can be scratched very easily. Like scratch can become, and we have generally we have seen these kind of scratch on these kind of transparent sheets over this. Yeah, and some other plastics such as polycarbonate. Polycarbonate is a very tough polymer we have read in the last session, which is more impact resistant, whether these kind of PMMAs and acrylic acids are very less impact resistance. Acrylics are widely used in windows nowadays. Windows are made from acrylic skylights and displays cases due to their glass-like appearance. They are also used in signboards, automotive light covers, medical devices, furniture, and aquarium tanks. Their strength, clarity, versatility make them useful in various applications, including construction, design, and consumer products. Here, aquariums generally made up of glass before. Nowadays, aquariums can be converted from these kind of polymeric sheets because they are already transparent and which have the lightweight than glass and easy to handle, of course. So this is how acrylics are, and if everyone has a basic idea about acrylics, so that we can study now more into the depth about acrylics by taking some questions. So starting with the first question, acrylics weather resistance is mainly due to its ability to withstand. So we have just read about that acrylics are weather resistant. So now they are asking about why they are weather resistant, because they can withstand high temperature, UV radiation, electric currents, or strong access. What among those options they can withstand? That's why they are weather resistant. Okay, I'm expecting some answers in this case. Okay, I got two answers, which says it's P, UV radiation. So let's see whether it's the true or not. So yeah, it's true. It's UV radiations because acrylics are mainly due to its ability to withstand damage from UV radiation. That's why it is whether it's acrylics, and why it is UV resistant is very important. And because acrylic have a chemical structure that inherently absorbs and blocks UV light to some extent, preventing the UV rays from breaking down to its polymer chains. Additionally, acrylic materials are often manufactured with UV stabilizers or absorbers, which is adding during the production. And that's how these additives also protect the material by harmful UV radiations and converting it to harmless heat, thereby reducing the degradation process. So that's how, because of the UV radiation blockage, because of the structure, because of the additives that we can give during the production process, these acrylics can help and can be weather resistant and can withstand damage from these UV radiations. If you look at the other options like the high temperatures, the electric currents, and the strong acids, so they are not that much, acrylics are not that much withstand these changes, but yeah, they can be withstand about the UV radiations, and hence UV radiations can be easily damage this your acrylics or your polymers. So moving forward with the next question, if anybody has any issue between anything, so they can ask me the questions in between also. So this is the next one. The acrylics are poor in resistance to which type of chemicals? So we have read in the previous question that acrylics are not that much resistant to chemicals, but now they're asking about which type of polymers or which type of chemicals they cannot resist very well. Acids, alkalis, alcohols, or water? Of course, if we look at the options, we can resist simply water. This is not a correct option. Yeah. And then we will give rest about acids, alkalis, alcohols, or hydrocarbons. Which kind of chemicals acrylics are poor in resistance? I got mixed answer this time. This is confusing, like whether acids or whether alkalis are poor in acrylic in poor in resistance of. So okay, let's look at the answer then. So yeah, it's not acid or it's not alkali, it's alcohols and hydrocarbons. And if you look at this, acrylics or like PMMA have a stable polymer structure with strong covalent bond, making them resistant to many chemicals, especially acids and alkalis. So they are resistant to acids and alkali, which typically do not react aggressively with the polymeric chain. And however, alcohols and hydrocarbons such as gasolines, oils, or certain solvents can interact differently. These chemicals tend to dissolve or swell the acrylic polymers by penetrating between the polymeric chain, weakening the intermolecular forces that hold the structure together. So here's a clip. They are saying that acids and alkalis typically do not react that aggressively with polymer chains because of their strong covalent bond. But alcohols and hydrocarbons, and if you look at the hydrocarbons, they are saying the organic moieties. And if you look at the structure of acrylics, they are also organic moieties. So such that the oils or the solvents, if we dissolve like PMMA, if you can take the acetone, not exactly acetone, the hydrocarbons like the toluene or the bigger hydrocarbons like those with different chains. And if you took those hydrocarbons and you try to dissolve it, this can easily dissolve or can swell the acrylics. You can check this by adding the PMMA into the toluene or into these kind of hydrocarbons. Like we have different chains of like C6, C12, C14, whatever hydrocarbon you have. So these kind of hydrocarbons tends to dissolve or swell the acrylic polymers by penetrating between the polymeric chain, weakening the intermolecular forces and hold the structures. So they are very poor in resistance with alcohols and hydrocarbons rather than acids and alkalis. So the answer is C, it's not A, and it's not B. Generally, if we look at the question, we generally think like acids are more strongest and they can actually damage the structure. Yeah, that's true. That's true in many cases. But in this case, in this case, if we look at this acrylics, they are very much prone to the alcohols and hydrocarbons because they can dissolve or they can swell in these kind of mediums. I hope this question is clear to everyone. I hope the confusion is also clear. And that's why I taken this question because I generally think that this type of questions can be easily like the acids or the alkalis. But no, this is not. And if we need to remember that acrylics are poor in resistance with alcohols or hydrocarbons. Okay, then moving forward to the next question or the topic. Let us see. Okay, so it's a topic and it's topic about polysulfide. And if you look at the elemental sulfur, which is acid, so, in the heating condition, this acid can be turned into structure like this, which can form the polymers, polysulfides. And if you look at because of the two-pronged structures, this kind of moiety can attach to it, forming the structure like this of polysulfide. And generally, it is a class of synthetic rubber-like polymers characterized by their chain containing sulfur atoms. And they are well known for their excellent elasticity, chemical resistance, and waterproofing properties. Because of these traits, polysulfides are commonly used in manufacture of sealants, adhesives, and coatings, especially in construction and aerospace industries, where airtight and waterproof seals are critical. They also offer good resistance to oil, solvents, and weathering, like the acrylics, which are not providing the good resistance to these kind of oils and solvents. Polysulfides, on the other hand, can provide good resistance to oil solvents and weathering, make them durable in harsh environments. So their drawback can be overcome by these type of polysulfides. And this is a rubber-like, so they generally show elasticity, the chemical resistance and waterproofing properties. That's why they are used as a sealant in the bigger industries like the construction or the aerospace or these industries. And these kind of industries like aerospace, we require the chemicals or the materials which are like very high impact or high impact, I can say, with the higher properties because there we cannot take any kind of risk with the cost itself. Okay, so let's take the questions on the polysulfides. So starting with the first question, polysulfides so good resistance to which of the following? So it's like water and oil, strong acids, high temperature above 500 or UV radiation. So polysulfides show good resistance to which of the following? Yes, now this is because we have played just the last slide. This is a now the easy question. This is not tough, that tough. Okay, so the answer is A, and I got to answer with say A, and it is very easy because we just read it that it can provide good resistance to water and oils, which acrylics cannot. And if you look at this, because polysulfide have a chemical structure and use sulfur atoms in their polymer chains, giving them excellent chemical stability and flexibility. And this makes them highly resistant to water and many oils, which is why they are widely used in waterproof sealants and coatings. Their molecular structure prevents water and oil from breaking down the or causing it to well, because acrylics have that polymer chain so that other type of the oils or the hydrocarbons can penetrate into between them, but has because of the flexibility, it is not that easy to disrupt the structure of polysulfide. However, polysulfide are not particularly resistant to strong acids or very high temperature above 500. So if you look at the other options, so they are not that good resistance to these, and these conditions can cause degradation or breakage of polymer chains. Similarly, they are susceptible to UV radiations as well, which can cause deterioration over time unless stabilized with additives. Therefore, they are best resistant to water and oils, making them ideal for applications needing durable waterproofing sealing. So they are saying that they cannot that UV they cannot resist UV as well as acids and temperatures, but that they can resist the waters and oils, and hence how we can decide like what kind of polymers can be used in which kind of field because we require a different and specific property like to seal this and to resistance from this. So that's how we can use different kind of polymers in that area. So that cases. This is clear. Yes, thanks. And let's move forward to the next question. So which industry commonly use polysulfide for their sealing and adhesive properties? That's a very simple question because we just read about this. So which industry commonly use these polysulfides for their sealing and adhesive properties like electronics, food, textile, aerospace, or construction? I think there's nothing to think about this question. It's a very easy one. Okay, so the answer is D. It says aerospace and construction because polysulfide are high valued in aerospace and construction industries because of their excellent elasticity, chemical resistance, and waterproofing capabilities. And that's how they can use in aerospace and construction because food and textile do not require such kind of high impact polymers. And electronics also, we can see that different type of, polyurethane, silicones, and epoxies can be used there. So the polysulfides can be used in aerospace and construction industries because of their excellent properties like this elasticity, chemical resistance, waterproofing capability. I hope till now this question is clear to everyone because we are like taking about different type of polymers and their properties. So that's how we are taking it. If anybody have any issue or any concern regarding this, please text me in the chat box. Okay, so let's move forward to the next question or the next topic. It's so here, it's not related to polysulfide, which is the question like how does temperature generally affect the dielectric constant of most material? So they are asking about like how does temperature generally affect the dielectric constant of most material? it remains constant regardless of temperature, it is increased with temperature, it decreased with temperature, or it fluctuates randomly. They're asking about how temperature generally affect the dielectric constant. Okay, now we are taking this like what is the dielectric constant and how it can be affect the temperature, but I want you to guys to try it. Like how the dielectric constant affect on the temperature. Okay, so here, interestingly, I got two answers. Like it increases with temperature or decreases with temperature. So let's first understand like what is dielectric constant, how it is related to temperature. And the correct answer is B, like it increases with temperature. And if you look at the explanation, so the dielectric constant, also called relative permittivity, is a measure of material's ability to store electrical energy in an electrical field. It tells us like how much electric charge a material can store as compared to vacuum. It highlights the dielectric constant means the material can store more electrical energy. Its dimensionless number and value is greater than or equal to 1. Vacuum has a dielectric constant of exactly 1. So if any component has a more than one dielectric constant, that means it can store the high electrical energy. Materials with high dielectric constant are used as insulators, incapacitors, and other electronic components to improve their efficiency. For most dielectric material, their dielectric constant generally increase with temperature. This occurs because rising temperature increasing the mobility of polymer molecules and dipoles within the material, allowing them to align more easily with an applied electric field. As a result, the material ability to store electrical energy, permittivity, or dielectric constant improves. So they are saying that generally the dielectric constant increases with temperature because if we increase the temperature of the mobility of molecules or the polymer molecules to the dipoles increases, and that can allow them to easily move or align them according to the applied electrical field. So that's why the dielectric constant generally increases with the temperature. I hope the concept of dielectric constant, dielectric constant, also known as the relative permittivity, is measure of material ability to store electrical energy in an electrical field, like how much material can store electrical energy in the electrical field. That's how the dielectric constant is. And the higher dielectric constant mean the material can store more electrical energy. And it's a dimensionless number. It's always either one in the case of vacuum, otherwise it is generally more than one. Okay, then moving to the next question. I guess, yeah, it's also related to dielectric constant. So they're asking like which of the following material typically has a high dielectric constant? Air, metal, glass, or vacuum? Which of the following material has a high dielectric constant? And we just read that the vacuum has a dielectric constant of 1. So apart from this, which material has the more dielectric constant? Okay, let's see what is the answer. So it's C, glass. Glass has a typically high dielectric constant than other. And let's see why and what is the reason. So the dielectric constant measure how well a material can store the electrical energy. Typically, glass has a high dielectric constant ranging from 4 to 10 depending on the type, meaning it can store more electrical energy to compare the materials like air or vacuum. Air and vacuum have the dielectric constant closer to 1, meaning they can store very little electrical energy. Metal, on the other hand, do not have a dielectric constant in the usual sense because they're conductors, not insulators, and they allow free movement of electrons and cannot store energy in an electrical field. Dielectrics do. And that's how, because mostly people, the student confused that the high dielectric constant means the material should be very conductive. No, it is not. But the high dielectric constant means they can store the electrical energy and cannot conduct, and that's how the insulator can move. The very good insulator can have the very high dielectric constant, and that's why the reason is the glass has a dielectric constant. Where among the options, glass is a typically dielectric material with a high dielectric constant rather than metals. Air and vacuum are out of the concept. I understand because we generally discuss with the air and vacuum has a dielectric constant related to one, that they can also generate a little bit or can transmit a electrical energy a little bit. But the glass is the insulator, and that's how they can store high electrical energy as others. Metals, on the other hand, cannot store energy, and they can allow free movement of electrons and cannot store energy in an electric field like dielectrics do. So that's why they cannot be used, and they have low dielectric constant than glass. So the option C is correct here, and I hope you understand the concept of dielectric constant and what kind of material show what kind of dielectric constant. You can ask with the different options also. So we generally need to look for the insulators, like whatever the material is higher insulator that have the high dielectric constant than the rest. I hope this is clear to everyone. So let us take the other option, the other question and the concept. And yeah, so what does a high dissipation factor in an insulating material typically indicate? So this is question about dissipation factor of an insulating material. And that shows the low energy loss and high efficiency, high energy loss and poor insulation, high mechanical strength, or high thermal conductivity. What does a high dissipation factor in an insulating material typically indicates? Okay, so we are already getting some mixed answers, which says either B or C. Let us see. So choose the correct options. Yeah, the answer is B, high energy loss and poor insulation performance. And the reason is the dissipation factor measures the energy loss in an insulating material when it is subjected to an alternating electrical field. So the high dissipation factor means the material convert more electrical energy into heat due to internal friction or the electrical leakage. This leads to greater energy loss, reducing the efficiency of insulation and potentially causing overheating or the material degradation over time. And this is how the dissipation, first the dissipation measure the energy loss. So it is typically the high energy low means high dissipation, and the other is the poor insulation performance. That means if the higher energy loss is happening, that means the insulation performance of that material gets poor, obviously. And this is how this is the great energy loss, reducing the efficiency of insulation, potentially causing overheating or material degradation over time. Therefore, a low dissipation factor is preferred in insulating material to ensure that effectively perform with the minimal energy loss. So the answer is B, high energy loss and poor insulation performance, which says the high dissipation factors means. And generally, that's how the low dissipation material with the have low dissipation factors is preferred in insulating materials. So we can see that the dissipation factor should be low and the dielectric constant should high of material to show the insulation characteristics better. Okay, I hope this is clear. So let's move forward to the next question. The power factor of an insulating material is defined as, now they're asking about power factor. So we have read about dielectric constant, dissipation factor. Now this question is about the power factor. So the power factor of an insulating material is defined as the ratio of resistive current to total current, ability of material to withstand mechanical stress, rate at which the material dissipates heat, or rate of voltage to current in AC circuit. So what does the power factor of insulating material signifies or defined as? Okay, I got two answers. I would say this A, ratio of resistive current to total current in the material. Let's see what does the power factor of an insulating material signifies. And yes, the answer is A, which is the ratio of resistive current to total current in the material is the power factor. The power factor is for insulating material is measure the material's energy loss. when the alternating current is applied. It is defined as ratio of resistivity or lossy current to the total current throughout the material. The total current includes both resistive and captivative components. A lower power factor means the material stores electrical energy efficiently with minimal loss, with a high power factor indicate more energy is lost at heat. This parameter helps evaluate the quality and efficiency of insulating materials in electrical applications. So this the lower power factor means that material can store more energy with the minimal loss, and that's higher. Uh, the higher power factor means energy lost is more, and that's how the effective and quantity and efficiency of insulating material is defined. If a lower power factor means the insulation properties of material is great, and the higher power factor or high dissipation factor also, like the power factor and dissipation factor right now is comparable, because in that case high dissipation factor also means the higher energy loss, high power factors also means the higher energy loss, and that's how their insulating characteristic decreases at that case. Whether the dielectric constant, on the other hand, is opposite to these kind of properties, and whether the material has a dielectric constant higher, that means the insulating characteristic of those material is higher. So I hope with this question, the power factor, the dissipation factor, and the dielectric constant, the definitions as well as the connection to the insulating materials or other things is clear to everyone. And because these are the very important factors, we just need to memorize which kind of these factors is showing which kind of properties. Okay, then if this is clear, so we can move forward with either of the next topic or the next question. So yeah, it's a question. So why is moisture absorption critical factor in evaluating polymeric materials for outdoor applications? So this is a very important question, a very normally देखा जाए. It's a good one. So why is moisture absorption a critical factor in evaluating polymer materials? Because it affects the material electrical conductivity, it improves the material thermal resistance, it can lead to swelling, warping, and loss of mechanical strength, or it enhances the material's UV resistance. Why moisture absorbance, and why what that are moisture absorbance? It can say like if how a polymer or how much a polymer can absorb moisture if we can keep it in the outdoor environment, like how it can absorb the moisture or what kind of property it is showing, swelling or these. So why this is an important factor in evaluating polymeric materials for outdoor applications. Okay, I got two answers, which can say it's can lead to swelling, warping, and loss of mechanical strength. Let us see. Yeah, it's C. Moisture absorbance is a critical factor for polymeric materials, and it can used outdoors because when polymer absorb water, they can swell or change in dimensions, leading to warping or deformation. So they can either swell because of the moisture. So that's an important factor. The physical changes can compromise the mechanical strength and structural integrity, causing it to weaken. And moisture can also accelerate chemical degradation process such as hydrolysis, further reducing durability. Therefore, controlling moisture uptake is essential to ensure the longevity and reliability of polymeric material in outdoor environment. So the correct option is C, because it can lead to swelling, warping, and loss of mechanical strength. That's why the moisture absorption is a critical factor in evaluating the polymer materials. So we can look for the material which cannot absorb that moisture, which can resist the moisture, so that it can be used in outdoor applications very good form. I hope this question is clear to everyone. So let's move forward to the next one. So yeah, this question is abrasion resistance. And abrasion resistance, if you look at the photo, is like if we are abrasing or we can for a polymer. So which of the following best describe what abrasion resistance protect the material from? Either surface wear due to repeated contact and friction, chemical breakdown, degradation caused by UV light, or structural failure under heavy loads. Okay, I got two answers, which says a surface wear due to repeated contact and friction, and it's correct because of the photo we can see like on again and again repeated contact and friction. That's why the abrasion resistance is, and that's how the abrasion resistance can protect material from. So abrasion resistance refers to a material's ability to withstand surface wear caused by mechanical action such as rubbing, scraping, or friction. When a material has good abrasion resistance, it can endure repeated contact with other surfaces without losing its integrity or surface quality. This property is essential in applications such as flooring, tires, or machine parts where constant friction is present. Like you can see that flooring, we can walk on the floor, and the tires, which can repeatedly in the contact of the road, and the machine parts, which can move, continuously moving. That's how this abrasion resistance came into picture, because that's why we need materials which can show good abrasion resistance in that case. Option B and C refers to chemical and UV degradation, which are different material of wear, and D refer to the mechanical strength with load, which relate to structural integrity rather than the surface wear. So the structure failure under heavy loads, this is a different property. This is not abrasion resistance. If we talk about abrasion resistance means contact, the direct contact or the continuous contact with the surface itself. And that's how we can measure the abrasion resistance. And we need such materials which can show better abrasion resistance than this, depending on where we use those materials. Okay, then. This is important. So in this session, we have taken many new concepts apart from just the introduction to polymers, different polymers and their properties. We have read about the dielectric, constant dissipation, power factor, abrasion resistance, moisture absorbance, and such properties, which is very important for the application. So the next property is the friction resistance. And friction resistance is important in material which can be used for electrical insulation, load bearing and moving, or thermal insulation. Why frictional resistance is important in materials? Okay, so I got two answers, which says it's C, bearing and moving mechanical parts. And let us see. Yeah, it's C. Because frictional resistance refer to the material's ability to withstand sliding or rubbing forces. You can have friction between the sliding or rubbing without excessive wear or damage. This property is especially crucial in bearing and moving mechanical parts, which is continuously moving, where the continuous contact and relative motion occur between surfaces. And that's how high frictional resistance help these components maintain their functionality for the longer time. And that's when you see when we add oil or some grease into the substance, because to grease the frictional resistance in between. So that's how the machines, because machines works continuously and their parts moves continuously. And if we add some oil or something, so they can reduce friction, and that's how the friction resistance can be improved, or can be, I can say, decreased. In contrast, this electrical insulation, load bearing, and thermal focus on other properties such as electrical resistivity, mechanical strength, and heat resistance, especially rather than the frictional resistance. Frictional resistance came where we talk about the properties like bearing and moving mechanical parts. So I hope this is clear. What is the frictional resistance? Okay, then let's move forward to the next. Okay, so this is the last topic of today's session, and this is the natural fiber reinforced composite materials. So first of all, we need to understand like of the every term, the natural fibers. So natural fibers are materials such as jute, hemp, flax, silk, coil, cottons. These are the materials which can present in nature. And reinforced composite material. Reinforcing means in a polymeric material where we can add these kind of natural fibers to improve the mechanical properties of final product. And that's how the natural fiber reinforced composite materials came into the picture because the properties, because they are very lightweight to the synthetic fiber, they are biodegradable and like environmental friendly. They can show good mechanical strength and stiffness, though usually lower than the synthetic, but still can be used. Renewable, important factor, thermal insulation properties is good and generally low cost. That's why these kind of natural fiber can be used in the composite material to reinforcement. Applications can be used in automotive component interior panel dashboards, construction like panels or boards, sports equipment like rackets and helmets, furniture, packaging, consumer goods, and that's how these the application area. You can see that the natural fibers like the mineral with asbestos, the animal like silk, wool, and hair, and the cellulose we can get from these kind of uh, agricultural waste or materials. And if you look at this different type of this, the mechanical, thermal, water absorption properties, the surface treatment type of metrics, and that's they can be used as additive, automotive, sports, multi-layer armor systems, and they can be used as a reinforcement type is continuous, discontinuous, interply, intraply. So that's how different type of these can be used at different type of metrics. Like the, I can say the small fibers can be used as the reinforcement, the sheets can be used as the reinforcement. So it depends what kind of property we are expecting. That's how this natural fiber can be used for reinforcement of the composite materials. Nowadays, this is a higher topic for the research itself, where people are using these different type of natural fibers and their different components to reinforcing and to show that the mechanical properties or the thermal properties are increasing very much. And that's how let us take some questions of this topic. The first question is, natural fiber reinforced composites are favored because what can they offer? They are heavier, have high excellent resistance, offer lightweight construction, and good impact resistance, or completely waterproof and resistant to all chemicals. So why these natural fiber reinforced composites are favored? Okay, so here I got two answer. Let's say this offer lightweight construction and good impact resistance, and correct. Natural fiber reinforced composites are popular because they combine the benefits of lightweight and good impact resistance, making them suitable for applications like automotive parts, construction, consumer goods. Compared to synthetic fibers, they are generally lighter, which have reduced overall weight in products and improve fuel efficiency in vehicles. And if you look at the other options like heavier, so no, they are lighter. Have high excellent resistance to high temperature. No, sometimes they cannot provide that resistance, and they are not that waterproof and resistance. We can make them waterproof by the chemical treatments or something, but they cannot completely waterproof. The only option which is correct is D, which can offer lightweight construction and good impact resistance to the materials. Okay, so let's move forward to the next question. So one limitation of natural fiber reinforced composites is that what is the limitation? They are highly resistant to moisture. They generally have lower strength and stiffness, are commonly used in aerospace, and are non-biodegradable and environmental harmful. Then by looking at the option, I can simply very easily say what is the limitation of these natural fiber reinforced composites. Okay, so by looking at the options, you can simply eliminate other like high resistance to moisture. No, they are not that high resistance to moisture, that they are not commonly used because in aerospace they are biodegradable. So the only correct option remains is B, which is these reinforcement composites are environmental friendly and lightweight, but one of their key limitation is that they usually have lower mechanical strength and stiffness compared to synthetic fibers, of course, such as carbon or glass fiber. They limit their use and application requiring high performance like aerospace and high structural component. So there we cannot use these natural fiber reinforced composites, but on the other applications or the other industries where we do not require such high impact or such high properties polymers, where we can use such kind of natural fiber reinforced composites by looking at the environmental safety issues and concern. Okay, so it's the last question. Which environmental factor is major cause of natural fiber composite deterioration? So what is that environmental factor? Moisture, humidity, conductivity, tensile strength, electrical insulation can cause these natural fiber composite deterioration. Okay, let's see. So it's A, moisture and humidity. The moisture and humidity are significant environmental factors that contribute to the deterioration of natural fibers. Natural fibers are generally hydrophilic, means they tend to absorb water. And the moisture absorbance can lead to swelling fiber matrix, which can cause weakening microbial growth and ultimately degradation of mechanical properties. High moisture content can also cause dimensional instability and accelerated chemical breakdown, reducing the durability of composites, especially in outdoor humid environment. They don't have high thermal conductivity. They, on the other side, they can be used in the insulation. They don't have low tensile strength. They can show different type of tensile strength and the electrical insulation. These are not correct option. Only correct option is moisture and humidity, because that is the important factor for that deterioration. You can see like if we put any of the agriculture or something material which we can store into humid conditions, that can microbial growth or the fungal growth can start very easily on that because of the moisture and humidity. And that's why these we need to think and we need to change these kind of fibers before using them. And that's how the natural fiber reinforcement composite can work. I hope this question and this topic is clear to everyone. So yeah, that's all for the today. And I hope the questions are very much clear and easy. If anybody have a problem, I can repeat it again. And apart from it, I can wish you all the best for the week 11 assignment 11. I hope that this questions you can solve this week 11 assignment very easily, and only the last session of this course remains, in which we are going to take on the next Friday, where we will read about the polymers and different areas or different industries we can use them. And I wish you all the best for this week 11. I hope that this session is clear to everyone. So, okay, have a nice day ahead. Thank you so much all.